Alright, welcome back to the class. Now we will start sedimentary rock, but before that we will learn about weathering of rock, the process of weathering, what are the different type of weathering and how does weathering makes new sediments and how the sediment combine together, lithify together to form sedimentary rocks. Weathering here, as the definition given in your slide, weathering is the transformation of a rock to reach equilibrium with its environment. So as the environment changes, the chemical nature of the rock may not be in equilibrium with the change with the new environment. So that's why this new environment will have an effect, a weathering effect, and it will transform the rock in the new weather or in the new environment. A natural response of materials to a new environment. It's a natural response. As the environment changes, the material will respond to the change in environment. There are two basic categories: mechanical and chemical weathering. Generally occur simultaneously, and then erosion is the process where it transports the sediments from one location to another. Mechanical weathering. So there are two different types of weathering. So we can, if we are writing about weathering, we can call one as sorry, mechanical, and the second one is chemical weathering. Okay, so mechanical weathering are three different types, or you can say four different types. One is frost wedging. Second one is salt crystal growth. This will occur only in the marine environment near the ocean. Third one is sheeting, and fourth one is biological activity. And chemical weathering, it is I think just one type. It is due to the presence of the chemical water and carbonic acid. So we will go more in detail about these different types of weathering here. Frost wedging, salt crystal growth, sheeting, biological activity under mechanical weathering. So let's go back to your slide. Mechanical weathering is the process of breaking down rocks into smaller pieces. So this is a figure from your textbook. You can look at figure 2.14. This is also a smart figure, figure 2.14 in your textbook. There is a link given in the caption of the figure. If you go into that, there is more animation, there is more explanation about this figure that further explains the concept of mechanical weathering. So here you can see there is this one big piece of rock. It is 4 square units in size, and here it is showing the idea of mechanical weathering. So as this big piece of rock, it breaks into smaller pieces, the exposed surface area continue to increase. So that is the most important part here in mechanical weathering. During the mechanical weathering, it increases the surface area available for chemical weathering or even for mechanical weathering itself. So every time a piece it falls off from here, it exposes a larger area of this bigger rock. Now it become more exposed to mechanical weathering. So here you can see in the original larger piece of rock, the exposed surface area was 24 square units, and as it breaks into a smaller smaller pieces, now its exposed surface area is 48 square units, and as it continue to uh, breaks into a smaller piece, the exposed surface area become larger and larger in size. So this all these faces of the rock which is exposed to the environment, that is what is given here. The total exposed surface area 24, 48 and 96 square units. So as the surface area, exposed surface area increases, the rock become more and more susceptible to weathering forces. So this is just the definition of mechanical weathering, that as the mechanical weathering continues, it continue to make the rocks more and more exposed to the weathering forces by breaking it down into smaller pieces. So look it up, your figure 2.14, smart figure in your textbook. So here is the first type of mechanical weathering called frost wedging. So this is based on the idea that when water freezes, it expands in volume. So around 99% expansion is observed when water reaches freezing point. Ice expands 9% when it freezes, and you must have observed this if you in your home as well. If you leave a bottle full of water in a freezer, then after some time that bottle will start to crack. You will start to see crack appearing on that bottle as long as the bottle was full of water, because the ice is tend to expand, and as it expands, it will start developing this crack on the bottle. And the same thing happen here in the geological setting. During the rainfall, this water will fill into the cracks or the pore of this rock or the mountain, or any topography even on the surface of the earth. The water, as it fills these pores in the rock, and as season goes from summer to fall to winter, this water which is trapped in the pore of this rock will start to freeze, and as it freezes, it will continue to expand, and that expansion will increase the pore size. As you can see here, the water, as it is going through multiple season of winter and summer, during the winter season it will expand the pore become larger, and when the summer comes, the ice will melt, and then water will flow away, and then during the next rainy season, during the rainfall, more water will fill into this expanded pore. So now the next time when the winter will come, the pore will have water which will freeze, and then it will expand further. So after going through multiple seasonal changes, the pores will continue to grow in size due to expansion of ice in the pore, and that will eventually starts to create this crack or fracture in the rocky mountain, and eventually that will starts to break down the rock or mountain. So that is called as frost wedging. When the water as it fills into the pore, going through the seasonal changes, it freeze and expand, and that increases the size of the pore. The coming next season, more water will fill, more expansion will happen, and eventually it will break down the rock. That is frost wedging. Another one is sheeting, which is no, I think there is another one, frost wedging and sheeting. Okay, sheeting occurs when entire slabs of intrusive igneous rocks break loose. So here is an example of sheeting here, and this is figure 2.17. Yes, so figure 2.17 in your textbook. This is also a smart figure. So look up the caption of this figure, and you have a link. You can go to that link, and it will show you some animation and explain the process of sheeting, so that will be helpful. So the process of sheeting, what happens here is you have these deep pluton intrusive igneous rock, which is confined under the overburden pressure, and as the weathering continues, this confining layer will continue to erode, and as this continue to erode, the pressure will decrease over the time on this intrusive or deep plutonic rock. And as the pressure will decrease, it will try to expand, and during this expansion process it will start to develop this crack or fracture, and then there will be this layer of rock that will start to fall off from the from this exposed plutonic rock. And this is where what it will look like. You can see these cracks and these layers, like an onion layer. It will start to peel off from the surface. So this is another kind of weathering called sheeting. The third one here is I think it's not here. There is another one called salt crystal growth. I think it's not in your slide, but it is given in your book. It mostly occur in this one, salt crystal growth. So this mostly occur in marine environment and during the sea spray. So what happened, the wave will spray a lot of salt water on the surrounding rock around the beaches, around the coastal line, where there is a line of these rocks, and those are sprayed with salty water by the wave action. And as the salt will fall on this water, the water will start to fill into the pore, and over the changes in season, when the summer will come, those salty water will evaporate and it will leave the salt behind. So the water will evaporate, the salt will be left behind in the pore, and over the years, as this process continues, something like frost wedging, but it is not just the water, but now in the marine environment it's a salty water. So the salty water will continue to fill, and during the rainy season, during the summer season, the water will evaporate, the salt will be left behind, and over the time more and more salt will fill the pores, and it will continue to expand the pore, and over the time and over the years, hundreds or thousands of years, that will start to disintegrate the rock. And that is another kind of weathering, or mechanical weathering. The last one is called biological activity. This is due to these plants. Here is a photograph of a plant which is growing its root deeper in the ground. So this is a tendency or property of the roots, that it will continue to grow in search of nutrition and food and water. So that is just a natural tendency of trees to grow its root longer and longer in search of nutrition, food and water. And during this process, it may come across some of these bedrock, and it will continue to grow through this bedrock, and while growing it will start to create these fractures or crack, as you can see here. Then that will start to disintegrate the original rock, and that will eventually break down the rock as the roots will continue to grow through this rock system. So this is about biological activity. And now let's look at chemical weathering. Chemical weathering uses some sort of chemical reaction to alter